typical probability question which involves a tree sketch. Okay, the question says, John tries a raffle. He has a probability of 1/10 of winning the raffle. He then tries a hoopla game with a 2/9 chance of winning. Okay, so what he's doing in this question is two things. He's trying a raffle and he's trying the hoopla. So he's trying two different games. So two events are taking place. Part A, draw a tree sketch. Okay, so this question here involves a tree sketch. In many questions in the exam, they will half draw the tree sketch for you and ask you to complete the picture. In this case, they're asking you to draw the entire tree sketch. Okay, I'll do the tree sketch over here. I'll answer the calculations down here. So for part A then, we've got a tree sketch. Two things going on. First thing is the raffle. Okay, so if you just watch and see how the tree sketch takes place. Like so. When John plays the raffle, he's got two choices, or two things can happen, and these are the two branches of the tree sketch. He can either win at the raffle or he can lose at the raffle. Winning at the raffle, you're told in the question, he's got a probability of 1/10, so there's a 1/10 chance that he's going to win at the raffle. That must mean that there's 1 chance in 10 of winning, there must be 9 chances out of 10 of losing. So 9/10 goes on that branch. The fractions must go on the branches, like so. Now that's the first thing that's happened. The second thing that's happened is he plays a hoopla game. So this is how we complete the picture. Imagine that he's won at the raffle, so he's followed this branch. He then has a go at the hoopla. What can happen? He can either win at the hoopla or he can lose at the hoopla. So this part of the picture is all about the hoopla. Let's imagine that he lost at the raffle. He then tries the hoopla. What can happen? He can win at the hoopla or he can lose at the hoopla. So there's the basic picture. We now need to add the probabilities on in each of the branches. So for example, when he's trying the hoopla, what's the chances he wins? Well, if you look at the question, you're told it's a 2/9 chance that he wins. So that must be 2 chances out of 9. So that must mean that there are 7 chances out of 9 that he loses at hoopla. 2 out of 9, 7 out of 9, if you added them up, they'd give 9 out of 9, which is 1 whole, which is a certainty. 9/9 is a certainty. It's a certainty he either wins or he loses at that game. Okay, so let's say he first of all lost at raffle, so he followed that path. He then tries the hoopla. What happens? He either wins, well, he's still got a 2/9 chance of winning, or he loses, he's still got a 7/9 chance of losing. So there you go, there is the tree sketch for this situation of playing the raffle and then playing the hoopla. Okay, I'll do the calculations down here. Part B. Part B says find the probability he wins at both. So winning at both means he follows this path. Win and then a win. So he's ended up there, following that top path. Win and win. So the way that you should structure it is, first of all, rephrase he wins at both as win and win. That's the first step. You need to restructure it so you have this win and win mentioned in the question. So win and win. The chances that he wins at the first game, which is the raffle, so follow that path. It's 1/10. 1/10 chance. Chances he wins at the second game, so that's this path. 2/9. Win 2/9 at hoopla. And then remember, in probability, if you want to win at that and win at that, in probability the word and gets replaced not with a plus sign as you might suspect, but with a multiplication sign. And gets replaced with multiplication in probability. So we do that calculation. To multiply fractions together, very simple. 1 times 2 is 2, and 10 times 9 you do multiply together to give 90. And that's the answer. Of course, that is a fraction which can cancel, so you should cancel it. You get 1/45. a 1/45th chance that he wins at both games. Okay, let's do part C here. Part C, I want to know the probability he wins once only. He wins once only. Not twice, once only. So that is basically the same as saying this. He wins at the first game, the raffle, and he loses at Hoopla. That results in one win. Or there's an alternative. The alternative is, I'll do it underneath here because I'm going to run into the tree sketch there, or he loses at the raffle and he wins at the Hoopla. Both of those sees him winning exactly once. Win and a loss, or a loss and a win. A win and a win is not acceptable because it says he wins once only. So he can't win both, and he can't lose both, obviously. So win and loss, or loss and win, is what we're looking for. And it's important that you phrase this in that way, with the words and in, and the word or in the middle, because or is a special word for probability as well. So here we go. The probability he wins and he loses. Win and lose is that path, ends up there. So it's a 1/10th chance to win, and is times in maths for probability. Lose is 7/9. So that's the chance that that path is followed. 1/10 times 7/9, a win and a loss. Or, now in maths, if there's an alternative probability path you can take, the word or gets changed to a plus sign, which you should remember. A plus sign instead of the word or. And then we say a loss and a win. Well, a loss first was 9/10, and times a win is, well, a loss and then a win. 2/9 is the win on the second game. So the second path has a chance of that, of happening. That is the second path, that one there. A loss and then a win. If you want that path or that path to take place, you add the two answers together. So let's multiply these out. 1 times 7 is 7, 10 times 9 is 90, plus 9 times 2 is 18, 10 times 9 is 90. So we get that. Now remember, when you're adding up fractions, what you don't do is say 7 and 18 is 25, 90 and 90 is 180. It doesn't work like that. If I said to you what's 7 cats plus 18 cats, you'd say to me 25 cats. This works in the same way. 7 90ths plus 18 90ths. Because they're both 90ths, the answer is just 25 90ths. So you do add up the two top numbers, but the answer is 90ths. 25 90ths is the answer. As you can see, 5 will go into both of these because this ends in a 5 and that ends in a 0, so 5 will go into both. So if you share the top number by 5, it goes 5 times. And then 5 into 19, well, it goes 18 times. If you don't know, then you have to do a sum, side sum if you can't do it in your head, if you haven't got a calculator. 5 into 90. 5 into 9 goes once, carry 4. 5 into 40 goes 18 times exactly. So there you go, there's the answer, 5/18. Very, very common type of question involving a tree sketch on probability, and that sort of thing is grade C standard. So on the harder paper it's going to be sort of around about the halfway mark, just before the halfway mark, just after the halfway mark, depending on how hard they make the question. It could be a C or a B grade standard. Okay. That's the end of this video. In the next video I'll give you another one or possibly two of these, slightly different, slightly harder.